All right, more trigonometric functions, okay? So we have a few more problems for you to do, similar to section 1. There are a few different things you'll see, though, that might be a little different than what you have seen before. So we have 4 sine theta minus 2 cosecant theta is equal to 0. So let's get it all into the same trig function. In that case, we can make that easily into sine, right? Because we have sine here, and we know that cosecant reciprocal is sine. So we have 2 over sine theta here equals 0. And we can't really have anything to do on there, so I'm going to multiply everything by sine theta. And we'll get 4 sine squared theta minus 2 equals 0. Because 0 times anything is 0. So we need a factor now, right? So if I factor this, I can just simply divide out 2 to make our lives a little easier. And then I'm going to isolate sine theta. And sine squared theta is equal to 1/2. Square root. I'm going to get sine theta is equal to 1 over root 2, or root 2 over 2. We should also know it could be positive or negative because we found the square root. So find all the values on your unit circle where sine theta would be equal to plus or minus root 2 over 2. And that would be 45 degrees, 135 degrees, 225 degrees, and 315 degrees. I put one too many 2's there. Ooh. So yeah, those are your 4 possible answers if we were doing between 0 and 360 degrees. 0 to 2 pi, give us your ratings, and that's going to be the same process. Second example, we got sine of 2 theta minus cosine of theta. What we see here, it should be a little familiar from last chapter, is we have a double angle formula, right? So what's the double angle formula for sine? Well, it's 2 sine theta times cosine theta minus cosine theta equals 0. Once again, we're going to need a factor. So GCF of these two terms would be cosine theta. And then you're left with 2 sine theta minus 1 equals 0. Okay? Send them both equal to 0. You're going to get sine theta is equal to 1/2. And then you'll get cosine theta is equal to 0. So once cosine theta equal to 0, let's keep it in terms of degrees. Let's do degrees for this one. Cosine 0 is 90 degrees and 270 degrees. And then sine theta is equal to 1/2 at pi. Well, no, I'm sorry. Well, no pi because we're doing degrees as we said. 30 degrees and 150 degrees. Okay, third example, we got 4 sine squared x plus cosine x minus 5 equals 0. Once again, we can't really do anything with this as far as factoring goes, no GCF or anything. So let's try to see if we can get into the same trig function. One thing we do know about sine squared x, you remember your Pythagorean identities, you might remember this one, sine squared x plus cosine squared equals 1. Right, remember that? So 1 minus cosine squared x is equal to sine x. So I can replace sine squared x with 1 minus cosine squared x. Distribute to 4. And then let's combine our like terms. And that's going to get us negative 4 cosine squared x plus 4 cosine x minus 1 equals 0. AC method, factors of 4 that add up to 4, well, that's 2 and 2. So negative 4 cosine squared x plus 2 cosine x plus 2 cosine x minus 1 equals 0. AC method, factor -2 cosine x, parenthesis cosine 2 cosine x, plus, well, -1 rather. Can't take anything out of the second pair, so it'll just be +1. 2 cosine x minus 1 equals 0. So I'm going to be setting -2 cosine x plus 1 equal to 0, and 2 cosine x minus 1 equal to 0. So when I isolate cosine x equals 1/2, and 1/2. Oh, same thing twice, okay? Which works out nice. So what values to input in the cosine will get you 1/2? That would be, let's do radians this time. Pi over 3 and 2 pi over 3. That's whenever values that make cosine equal to 1/2. Use your unit circle and you'll be able to see it. This is our last example together, and this one can be a little tricky, okay? So once again, we have two different trig values. We can't do anything with them because they're not reciprocals. None of the rules can come into play, but what we can do, if I add cosine to the other side, and we can force it to be an identity. We can square both sides. This should have been sine, I'm sorry. I changed it on us. Square both sides, we're going to get 3 sine squared theta. And on the other side, once I FOIL out, it'll be 1 plus 2 cosine theta plus cosine squared theta. Okay. Now we can apply your Pythagorean identity. Once again, sine squared theta we know is equal to 1 minus cosine squared theta. I'm going to see with 3. And then it's going to come out to be a similar problem as the others, in that we need a factor. Move everything on one side. If I add this to the other side and subtract the 3 to the other side, that's going to get us 4 cosine squared theta plus 2 cosine theta minus 2 equals 0. Divide out the 2 to make our lives a little bit easier. And then we can do our AC method. Factors of -2 at the positive 1 is 2 and -1. So we get 2 cosine squared theta plus 2 cosine theta minus cosine theta minus 1. Factor out 2 cosine theta. And then factor out -1. And then set them both equal to 0. You get 2 cosine theta minus 1 equals 0. So cosine theta equal to 1/2. And then cosine theta equals -1. For the other one, because I just subtracted 1 to the other side, so what values of cosine theta equals 1/2? We'll do radians again, so let's just do pi over 3 and 2 pi over 3. Cosine theta is equal to -1. That's pi. So your 3 solutions are pi, pi over 3, and 2 pi over 3. I appreciate you watching, and we'll see you in class. Bye-bye now.